right, so today we're going to talk about the third way to solve the systems of equations, which is by using elimination. So, the warm up, solve this first equation using substitution. All right, so here I'm going to start by solving this one for x, just because I have x all on one side. So, I divide everything by 5, and you get x equals 3 plus 2y. And I'm going to take this and replace my x right there. So, you get 3 times 3 plus 2y plus 7y equals 31. Distribute in your value, you get 9 plus 6y plus 7y equals 31. Combine like terms, 9 plus 13y equals 31. Subtract 9, 13y will equal 22. And then here you can divide by 13 and you're going to get a decimal, and that's okay. So we get y equals 1.69, and we want to plug that back in up here. So x equals 3 plus 2 times 1.69. Type that into your calculator and you get 6.38 for x. Okay, so how do you solve using elimination? The idea here is you want to figure out which variables have opposite coefficients, and if they don't, you want to make them have opposite coefficients. So looking here, our x's are opposite. So we can take these two, and you're just going to add the two equations together. So negative 4x and positive 4x are going to cancel. And then here you're going to get a positive 6y. Negative 12 minus 24 is negative 36. And then you can divide both sides by 6, and y equals negative 6. Now, you're going to take that negative 6 and you can plug it back into either equation. So you can replace this x or this x. It doesn't matter. Both of them, replace the y's. You can replace this y or this y with negative 6 and solve. It doesn't matter which one. So I'm going to do this first one. We have negative 4x minus 2 times negative 6 equals negative 12. Negative 4x plus 12 equals negative 12. Minus 12 minus 12. Negative 4x equals negative 24. Divide by negative 4. And you get x equals positive 6. So your point solution would be 6, negative 6. All right, so here, same idea. You want to figure out, well, which two have the same coefficient but opposite? And we can look at our x's again. So those will cancel. We'll get 9y equals negative 9, y equals negative 1. And then again, you can plug it into either one. So I'll plug it into this second one this time right here. So you have 4 times negative 1 plus 6x equals negative 10. Negative 4 plus 6x equals negative 10. 6x equals negative 6. X equals negative 1. So your solution is negative 1 for this one. All right, you try this one. Okay, so we can add these two together. Those will cancel out, and you'll get 10y equals negative 10. Y will equal negative 1 again. And then you can plug this into either y. I'm going to plug it in to that one. So negative 4x plus 2 times negative 1 equals negative 30. So then you'll get negative 4x minus 2 equals negative 30 right there. And then we can just keep going with this. So negative 4x will equal negative 28, and x will equal 7 when you divide. All right, so what if they aren't already opposite coefficients? What if it's not set up how you want it to be set up? Well, then you can multiply the whole equation by something to get what you want. So here we have a 4x and a 2x, so it'd be pretty easy to multiply by 2 and get that to be a 4. So I can multiply this entire equation by negative 2, and it will come out how I want it. So you'll get negative 4x plus 10y equals negative 28. So make sure this 2 is going to every single value. And then I can just rewrite the other one and add. Those will cancel. You'll get 17y equals negative 34. Divide, and y equals negative 2. Again, you can plug this back into either equation if we plug it in up here or into right here. You get 2x minus 5 times negative 2 equals 14. 2x plus 10 equals 14. 2x equals 4. X equals 2. All right, so here's another one. We want to get some opposite coefficients. This one's not quite as obvious what we can do. So we have a 4 and a 3, an 8 and a 10. Like, how can we get them to be the same? If you're not sure, you can take your two smallest numbers and multiply by that. So I'm going to multiply this one by negative 3 and this one by positive 4. So like switching these two, and then we'll see if we get the same or what we want. If you don't, you can always go back and try again. So negative 3 times each of these will get negative 30x minus 12y is going to equal positive or negative 36 right there. And then we can distribute the other one through. You're going to get positive 32x plus 12y equals 44. Here it worked. We can cancel those out. You'll get, positive 2x equals positive 8, x equals 4. And then you can plug this into either one. Plug it into this x right there. 10 times 4 plus 4y equals 12. 40 plus 4y equals 12. Subtract 40 from both sides. 4y will equal negative 28, and y equals negative 7 when you divide. All right, so this is another one. Another example right here. So we could do this, or we're going to skip this one just because we've kind of done a lot of examples. You can try this one if you want to try it, but when we were doing these, there's lots of different methods. Like we talked about 3. There's graphing, there's substitution, and there's elimination. So how do you pick which one to do? It kind of depends on your preference. If you like graphing, you can do graphing, unless it tells you what one to do. But if we're looking at this, we already have a y equals, so it'd be pretty easy to take this and substitute it in. So that would be my recommendation. You could do elimination. You need to move the 6 over so you get your equation the same. But you really can do either one. I would say the best method for this one would be substitution. So that's it for this chunk. You want to work on 6.3.1 Math Excel.